Hey guys, I am Shannon. I am a software architect in a USA company. In this course, we will talk about AWS code deployment. Actually, we will create a project with using Spring Boot. Then we will deploy this project to the EC2 instances with using CodePipeline. And we will go on with step by step. Let's start. In this section, we will create our Spring Boot application and we will import it to IntelliJ. To create a Spring project, the best way is using spring.io. We can reach Spring.io from start.spring.io. First of all, we should choose our project type. Our project will be a Gradle project, but if you want to go with Maven, you can choose it also. We will use Gradle because Gradle has easy configuration and better performance than Maven. Secondly, we will choose our language. Our language will be Java. Our Spring Boot version will be a stable current version. Our group name will be com.sha. Our artifact name will be AWS CodeDeploy demo. Last thing about project metadata is to choose the Java version. We will go on with Java 11. That's all about metadata. Let's choose our dependencies. Actually, we will only use web dependency because we will use the model view control structure on our service. Okay, that's all about dependencies. Now we can generate it. We are almost ready to start programming. Now we will import it to IntelliJ. In this lesson, we will go on with IntelliJ, but if you want, you can go on with Eclipse or other frameworks. Okay, now we are ready to start coding. To test our system, we will create an example endpoint. To create it, we will create an example RestController class. For example, we can create a class like API controller under the controller package. To describe API controller as a RestController class, we will add RestController annotation to it. Then we will create a health check method. In the RestController, we can define every method with using response entity capsulation. Response entity is a capsulation that contains HTTP header, HTTP status, and response body. For our health check method, we will create a get mapping and our endpoints will be API health. Finally, we will return an example success message. Okay, that's all for Spring Boot project. In this section, we will create AWS CodeBuild config file. On AWS with CodePipeline, we can easily implement continuous integration and continuous delivery processes. We simply have to commit our changes and the CI/CD configuration will automatically test our code and deploy it to the server. To do it, we will create a configuration file. Our file is buildspec YML. This file specifies the steps needed for the build process. We can find the details of it from AWS documentations easily. We can see the example templates. Let's create it under our project. The name of it will be buildspec.yml. Version represents the build spec standard being used in the configuration. Phases represent the stages that we want to instruct CodeBuild to run commands. Phases can be installed, pre-built, build, and post-build. In here, our goal is to build our Gradle project. Then we will specify the target jar path. On the artifacts part, we should specify what we will need at the end of the build process. In here, we will need a jar file. We can find the exact path of it from the build process. Let's build it from Gradle part with boot jar. It will take some couple of time. Okay, we can find it from under the build and libs and jar. Okay. Then we will need some scripts that we will implement for code deploy, etc. We will handle it later. The last thing to discard paths will be yes. It is what throws away our directory structure. It essentially flattens our artifact set. We can find the example case for it from AWS documentation page. Okay, our build configuration file is ready now. On the build stage, we need to tell CodeDeploy how to deploy our application on the instance. CodeDeploy uses a YML file, which by default is named appspec YML. We can find the details of it from AWS documentation page easily. The template is constructed from files, permissions, and hooks sections. Now we will create our appspec YML under our project. Appspec YML. We will provide information to CodeDeploy about which files from our application revision should be installed on the instance during the deployment's install event. After code build, we will copy all source code and we will pass to the under server directory. The permissions section specifies how special permissions, if any, should be applied to the files and directories folders in the file section after they are copied to the instance. The content in the hooks section of the appspec file varies depending on the compute platform for your deployment. The hooks section for an EC2 on-premises deployment contains mappings that link deployment lifecycle event hooks to one or more scripts. On hooks part, AWS presents different lifecycle events. Lifecycle starts before the application revision is downloaded. First step is application step. This deployment lifecycle event occurs even before the application revision is downloaded. In this step, we can specify scripts for this event to gracefully stop the application or remove currently installed packages in preparation for a deployment. Then download bundle step. The CodeDeploy agent copies the application revision files to a temporary location. Then the CodeDeploy prepares installation. Before install, it calls before install event. After install it calls after install event. After installation, the CodeDeploy restarts all application services. The name of this step is application start. And finally, to validate the status of application, it provides the validate service step. In here, we will see the most lifecycle steps one by one. Our first step will be before install. On before install step, we will call a script file. On this script file, we will remove the previous application files. Our application will be deployed to the under the server directory. So in here, we will remove it. Secondly, we will fix the script privilege after installation. Actually, we don't need to do it in most cases, but to show the lifecycle step, we will examine it in here. For the server directory files, we will give executable privilege. On application start tab, we will start our Java application. You know that we can do it with using Java jar command, Java jar plus jar path from the console. But first of all, we should open our application directory. Then we will execute our jar file. In here also we can pass environment variables like port number of active Spring profile, etc. Also in here we will throw away any error message with using Linux special commands. Finally, on the application stop step, we will kill all Java applications application stop server stop sh. Finally, scripts and appspec YAML files need to be included as artifacts on the build result, so we should edit the buildspec YAML to include them. Okay, now our appspec file is ready. In this section, we will create our Github repository and we will send our code to this Github repository. To do it, first of all, we will open our Github dashboard. Then we will click to New Repository button. Then we will specify our repository name. Our repository name will be Spring Boot AWS CodeDeploy demo. Then we can set access rights. In here we will set it as public, but of course you can go with private mode. Then we can create it. Actually, GitHub says what we do to import our code here. First of all, we will initialize Git on our project. Then we will add all items to Git. Then we will relate our remote repository with this project. Then we will commit our codes with a commit message. Finally, we will push it to a branch. In IntelliJ, we can do it via commands or we can do it via user interface. In here, our Git commands are ready, so we can use these commands from the terminal easily. Init, add, relate, commit, finally push codes. Okay, now our code is reachable from GitHub as public. In this section, we will create service access roles for CodeDeploy and EC2 machines. Let's open AWS console. In default, AWS services couldn't reach each other without permission or role, so to handle it, we will create service roles according to our deployment architecture. We can handle it from AWS IAM, so identify and access management service. From the left side menu, we will choose roles, then we will click to create role button. Actually, in here we will have two main roles according to our deployment architecture. Our main services will be EC2 and CodeDeploy. EC2 will communicate with CodeDeploy, so first of all we should choose it. We can choose full access or EC2 role for CodeDeploy. Then we will give a tag and name for this role. EC2 also will communicate with S3 because AWS will download code from GitHub to S3 on the backend. Then EC2 will fetch code from S3. So we also need S3 access to EC2. Let's attach it. S3 full access. Okay, that's all for EC2 role. Now let's choose for CodeDeploy service. Our second role will be for CodeDeploy service. CodeDeploy will have a typical AWS CodeDeploy role. Then we will give a tag and name for this role. Okay, now our main service roles are ready. In this section, we will create our EC2 instance. EC2 is another service of AWS, so we can find it under services easily. Then we will launch instance from EC2 dashboard. EC2 represents different operating systems and different instance types. In here we will go with Linux. Our instance type will be micro. Actually, we can choose it according to our needs. EC2 represents different instances according to CPU, memory, storage, and network. From instance details, first of all, we will choose our predefined role. Secondly, we will describe initial frameworks. For example, on our EC2 instance, we will call a Java project, so we need it, and we create the code deploy process, so we need a code deploy agent. We can find Linux commands from AWS documentation easily. We can find it like AWS Linux code deploy agent installation. From the documentation page, we can copy and paste them one by one. EC2 machine will also reach the S3 bucket. Code deploy S3 bucket name will vary according to region. In our case, we will use North Virginia, so it is US East 1. You should choose according to your AWS service region. In here, we should also add the AWS command line interface library. By the way, I will add all these commands to Github Repository so you can reach them easily. Finally, we will add a command for Java 11 installation. We can find it from Google easily. Okay. Then we will go on with general purpose SSD storage. In here, tagging is important because we will find the EC2 machine with using tag name on code deploy steps. Tag name can be demo EC2 for code deploy. Then from security group, our EC2 machine will be reachable from 80 port because port number of the Spring Boot project will be 80. If you remember it, we decided it on appspec file. Then we can see the summary dashboard of our EC2 instance. Then we can launch it. We can use existing key pair or we can use a new key pair to connect our EC2 machine. This key pair file is a credential private file to connect our EC2 machine from localhost. To launch it will take some time. We can see the status of it from the EC2 dashboard easily. When it is ready, its status will pass from pending to success. Okay, now our EC2 machine is ready. In this section, we will create our code deploy application. The code deploy application will be our deploy provider. To create it, we will use AWS CodeDeploy service. From the side menu, we will choose Applications. Then we will click to New Application button. Application name will be CodeDeploy Demo. We will deploy to EC2 Instance. CodeDeploy also provides Lambda and ECS platforms as deployment sources. Next, we need to set up a deployment group. This is where we tell CodeDeploy the instances we need to deploy our application to. In our case, we will be using the tag we created for our EC2 instance to create the deployment group. We can, however, even mention an autoscaling group if we want to. Our service role will be the predefined role. Blue-green offers the safest approach by spinning up a separate environment complete with resources, running the latest version of our application. In place, uses the current resources to deploy code. We will use EC2 Instance to create the deployment group. We select the tag we created before to identify the EC2 instance. For our case, we don't want to follow agent updates, but I recommend it. Deployment configuration is related with multi-instances. If you use multi-instances, you can choose the deployment attempt type also. All at once attempts to deploy to all instances at once. The overall deployment succeeds if deployment to even a single instance is successful. It fails only if deployments to all instances fail. Half at a time deploys to up to half of the instances at a time. The overall deployment succeeds if the application revision is deployed to at least half of the instances. Otherwise, the deployment fails. Once at a time deploys the application revision to only one instance at a time. We can also use load balancer, but we don't want to use it for our case. From advanced settings, we can enable rollback options. We can roll back our application to previous versions. Okay, now we can create it. Okay, now our code deploy application and group are ready. In this section, we will create our code build and deploy steps with CodePipeline. Our code deploy steps are constructed from 3 steps. These are, firstly, fetch code from Github Repository. Secondly, build this code according to our buildspec YML configuration. Thirdly, deploy this build to EC2 Instance according to appspec YML configuration. Actually, we will create a pipeline for it. To do it, we will use AWS CodePipeline. Under Services, we can find CodePipeline. On the Pipelines page, we will click to create pipeline. First of all, we should describe a pipeline name. Our pipeline name can be demo pipeline. On AWS, we can use specific roles to share different jobs. In here, we don't have any existing role, so we will create a new role for it. We will use default settings, but in advanced settings, there is an important thing. CodePipeline will use S3 storage for temporary files. For this kind of thing, we can create specific S3 buckets, or we can use the default S3 bucket. In here, we will go on with default settings. Then we will click the next button. In the second step, we should choose a source provider. We will choose GitHub, but we can integrate GitHub with 2 different options. In GitHub version 2, we can clone repositories to access Git metadata in subsequent CodeBuild actions, while in GitHub version 1, we can only download the source. In here, the recommended way is to go on with version 2 by AWS. For our case, both versions can handle our problem. Let's go on with the version 1. In here, first of all, we should create a connection with GitHub. Okay, now our GitHub connection is ready. Then we will choose a GitHub repository. We can search it easily. Spring Boot, AWS CodeDeploy demo. Then we will choose a branch, master branch. We can also use GitHub metadata like releases, tags, etc. on AWS. To do it, we can go with the full clone option, but in here, the default mode will be enough for us. In the third step, we should choose a build provider. In here, we will use CodeBuild. Our region should be the same with our main region. Then we should have a project to specify the build machine. In here, we can create a new project, or we can use existing projects. Let's create a new project. Our project name will be demo CodePipeline builder. We will use the Linux operating system. Runtime will the standard configuration, and we will go on with the latest Linux versions. We don't have a Docker image. On AWS, we can go on with Docker deployment also. We will create a new service role because we don't have an existing role. We will use buildspec file. Actually, we have already described it on our Spring Boot project. We have a single operation. We can track all logs from CloudWatch about pipelines. We don't have S3 service on our project, so we don't need it. Okay, now our project is ready. We can pass some custom variables to build spec files with environment variables, but in here we don't have any custom variables. We have a single build, so we will go on with the single build. If we have a multi-module build, we can go on with batch build. In the last step, we should choose a deploy provider. We will deploy our code to EC2 Instance, and EC2 Instance provider is CodeDeploy agent. Then we will choose our CodeDeploy application and environment. Before we trigger it, we can see the summary of the pipeline. First step will be the pipeline configuration. Second step will be fetching all source code from GitHub. Third step will be the build source code with AWS CodeBuild. Then once the build is successful, it will be deployed to AWS CodeDeploy. Then we can click to create pipeline. Firstly, source code will be fetched. When it is completed, we will see the green tick on the right side. Then code build will be started. We can see the logs of the build. Let's open it on new tab. This will take a couple of minutes. Okay, build successful. Finally, deployment will be started. It will take a couple of minutes also. So once it will be completed, we can access our application. Okay, now our deployment looks ready. To reach it, we can open the EC2 dashboard. We can go to details of our EC2 instance. Then we can reach our application with the EC2 public IP or URL. Okay, now our deployment is ready. Now we can test our endpoints with EC2 URL. Our test endpoint is API health. Okay, everything looks perfect. That's all. Thank you.